Welcome to today's episode of EinfachEinfach. Today we want to discuss an industry topic that is becoming an IT fundamental: RESTful API. RESTful API is a communication interface or method between different programs, an API, an application programming interface. The definition of how information and data is exchanged between different programs. REST means representational state transfer, the transfer of data at a given state. Before using interfaces, applications were monolithic. They were programmed as a single complex in one language. This made the programs inflexible and difficult to maintain. But even more difficult, it was to choose the right programming language. Why is it difficult? You have to choose one language. And programming languages have different strengths. Some are good for fast, optimized programming. Others focus on big data and data science. And still others on the use of the internet. Different languages for different tasks. APIs enable every department in a company to use the optimal language for their purpose. Anyone could create small modules and then let them communicate with each other. With that came new problems. Changes in the API interface caused changes in many modules, and scaling was difficult. We will see how this was resolved with RESTAPI. RESTAPI is basically based on a client-server architecture. One program has the answers and the data, the server, and another one has the questions and want to access the data, the client. Then the REST API is based on communication techniques on the internet. This means that HTTP requests are used, like GET, PUT, POST, DELETE, and a few other methods, just like browsing the internet. These are the activities or verbs of communication. The answers are usually given in standard formats, such as HTTP, XML, or JSON, and are therefore easy and universal to understand. Like our daily browsing in the internet. When browsing, we send GET when we want to see a website. We request the content with GET and the website. The response is often a 200 OK and the website in an HTTP format, or it comes back in error. Most famous, maybe 404, website not found. I think we are all used to this error message. When we upload files to the internet, we use POST. If we want to change the posted element, we work with PUT. And with DELETE, obviously, we delete the element. In order to enable scalability, the REST API is stateless. The status of the client asking is unknown. This means each request must be closed in itself. An example. Let's say I'm on vacation. We talk on the phone and you ask, "Hey Sasha, where are you?" This request is stateless. All information is included. I will answer, for example, in Noordwijk by the sea. You may ask, "What's the weather like?" This request is stateful. We know you ask me how the weather is where I am. But from the question itself, it could be the weather with you, with me, on Venus, or anywhere else. So we need the context to answer the question. The stateless question would be, how is the weather in Noordwijk by the sea. The advantage of this approach is clear. The first question, what is the weather like, can only be answered correctly by me. The second question can be answered by anyone with access to weather data. This question scales. Another aspect in REST API is that it is designed as a layered system. If a system needs to contact other systems for further information, this is done transparently in the background. A side effect is that you can build a REST API gateway for a legacy application. This hides the legacy system and enables modern communication. Those basic elements of the REST API enabled scaling. The second problem was the changes to the API interface. REST API uses versioning for this. In the request, the client communicates the version of the interface with which it is communicating. If there's a newer API on the server can respond in the old format, as the old version is still supported for a while, and give back a warning in return to the client, which can be found in the logs afterwards. So the processes itself are keeping going, and the clients can gradually be converted. This standardized interfaces with its properties makes it possible to automate a wide range of systems, entire data centers that are controlled from a single central point. In this context, Swagger or Swagger UI are often used. This is a definition of the documentation of the interfaces of a service as well as REST API services, with a corresponding user interface to easily interact with this. This means, on the one hand, the interface definitions are machine readable and can therefore be easily integrated and tested without programming knowledge. You also have a kind of up-to-date documentation to look up the corresponding interfaces and to try them out by the push of a button. Let's take an example from NetBackup, this time without Swagger, but step by step through the details. First, we come and see the login request. In this example, we use curl. It's a typical Linux command line tool to exchange data in a network using various standard protocols. -X describes the request to be carried out. In this case, we go to the master server to do a NetBackup login. We send the data, the login request, to the master server, so it's a post request. The URL goes to the server with the path /netbackup/login. This describes the action, netbackup login. -H describes the header. The data format of the transmission is defined here, JSON, and the version of the API that is used. -D is the data section. Here we find the data to be transferred in JSON format as defined just in the parameter before. In that case, we use 4 attributes: the type of the domain, the name of the domain, my domain, the user, and the password. Now the server. The server reacts to this with a response that we see here. The JSON format is used again, and we see 3 attributes. First, the token that we use for authentication afterwards. It's a long thing, but we have to remember this. We will use it in the next requests. Then we see the token type. It's bearer. The following requests no longer have to be signed. And there's a validity as a third option. 68,400 seconds, corresponding to 24 hours. In the next step, we see many similarities to the first request. We see we use curl again, but this time it is a GET request, which means we are requesting information to us. The destination is the master server again, but you see the path is different. /netbackup, /admin, /jobs, /5. So we go on administrative tasks with the jobs, and in this case we selected the job with the ID 5. The JSON format is used again in the header, and in this case a version 2.0 of the interface. In addition, the authentication is carried out by the generated token, which we attach accordingly. The JSON response now describes the attributes for job ID 5. In addition to the expected information about the job, there is a section in the answer which is noteworthy, the links section. This section describes other ways to further interact with the job. For example, we have got here a hint how we could get the files listed that are used or touched by job ID 5. With these simple and standardized options, the interactions has been significantly simplified. Seen in this way, the definition and the use of REST API is a real simplification and acceleration of automation. And for most automation tools, REST API is a standard protocol that they use to optimize, automate and run data centers. It is integrated with NetApp Backup.